It's another Mate here with Teacher Jenny. Join me for another discussion, and this time this is about random sampling technique. Now, what is random sampling technique? When you say random, you are now choosing your sample based on chances. So there will be no bias on this one. Sometimes it is called as non-bias sampling, or this is simply called probability sampling because our sampling or the selection there of our sample is based on chances only. So let's try to know the different types of random sampling technique. The first one is lottery or simple random sampling. Now, from the word lottery, meaning to say you are going to base your selection merely on chances. So there are different ways of doing the lottery sampling here, or the lottery or simple random sampling. So the technique here is for you to either write the names on, you may have here the wheel or the roulette. You can write the names of your population member on the roulette, and then you can simply click it and then spin the wheel, and then once the name is, or once the wheel stop and there's a name pointed to as this one here, that name is now part of your sample. So that becomes part of the selected sample. So here, the first name is Jessa. So meaning our member of the sample is now with Jessa. So this is now dependent on how many are you going to choose as a sample. So let's try to spin again. And the next one is Iram. So that is now how you choose your sample using a lottery or simple random sampling. And of course, you're using a wheel as the medium of choosing your sample. Now, sometimes you may have it with number on it, and then there will be a list of the population, and there will be the assigned names on the numbers on the population. So you can also do that one. Another way of doing the lottery or simple random sampling is through draw by lot. So you will be drawing names of the population. May it be in any container, or you can have it in a hat or a box or a fishbowl. Now this method is known as fishbowl method because you will be literally using a fishbowl here in which you are going to draw the names as the member of the population, and or numbers as representations of the names of the population. So whoever you've got there will become your sample. Let's say, for example, I've drawn on that container and I've drawn Jenny as the name. So Jenny now becomes part of the sample until you're done with the entire sample size. So that is again lottery or simple random sampling. Now, next we go to the different type of sampling technique. We have here systematic random sampling, in which from the name itself, when you say systematic, you are following a system here, in which a system is composed of different steps or procedure or process to follow. So what is that, or what are the process or the steps in here? So first, you must have the list of the member of the population, of course. And then right after listing down, you are going to compute for the interval. See, there is a system there. You will be computing for the interval, in which that interval will be naming the list or the people or the person or your subject. That will be naming your subject as to whoever will be part of the sample. And right after getting the interval, of course, you will have to draw the number which is a starting point. So you have to have a starting point in which you will be adding your interval on it, and then right after that one, you will be continuously adding to the result with the interval in there. Now, the starting point, we will have that one based on the number 1 to 30. So this is the commonly used starting point. So this will be from 1 to 30. Now, you will be choosing or selecting the starting point, but you will not be the one to choose it. Instead, you will be going to draw, or you are going to have it in a simple random sampling or lottery sampling. So you will be drawing by lot in there the numbers 1 to 30. Now, let's say for example, I've made a draw and I've drawn 5 on it. So that means to say that the starting point is the number 5. So the number 5 in there will be part of your list on the sample. So if this is your list, then that would simply mean that you will be looking at the number 5 on your list. So this is 1, 2, 3, 4, 5. So Oliver will be part of your list. And then once computed the interval, let's say for example, your population is, hold on, let me change my pen. So let's say your population size is 20. This is a small population, I know that, but just to give you an idea of what to do, so let's have just 20. And then, of course, I wanted to have a sample size, which is, I guess I can have it in terms of 4, because I wanted to have a whole number in there. So more likely there will be a step for you or a procedure for you to get the sample size later on. But since we're not yet on that topic yet, so let me just have it as my desired sample size as 4. So 20 divided by 4 is simply 5. So that means that the interval here is 5. So from that starting point, which is 5, I will be adding it with the interval, which is 5, and that comprises my next sample or member of the sample. So if Oliver is on the list as the number 5, so I have Oliver, the next list on my sample will be the 10th person, because we're having it in intervals of 5. So we have 6 is Sebastian, 7 is Liam, 8 is Aidan, 9 is Gabriel, and then 10 is Lucas. So the next one on the list will be Lucas, and then and so on and so forth, until I have here 4 as my sample. So that will be how you are going to do systematic random sampling. Okay, and by the way, adding 10 by the interval, which is 5, that makes it 15. Sorry, on the list, I've got only 12 in there. So that means to say we still have 2 more members of the sample size that we, or the sample itself, as we are going to look for. Okay, so that is how you do systematic random sampling. So we're following a system in getting our sample. So we go for the stratified random sampling. Now, stratified random sampling, this is now in terms of groups. Now, when you say stratified, the groupings here is in terms of homogeneous groupings. Now, homogeneous meaning to say we're having a group with similar characteristics on it. Now, what are those similar characteristics? Let's say, for example, we're grouping our population in terms of their gender. So the gender there is homogeneous because we will be grouping, let's say, for example, this one here is a class or students inside a classroom. So if we are having stratified, I will be grouping them according to their similarities, and one of which is gender. So I will be grouping them according to girls, and I will be grouping them according to boys in there. So that is how you are going to do stratified, or how you are going to take on stratified. Now, how to do the selection when you have stratified random sampling? Now, this is done by simply dividing your students. Let's say since we're talking about student, we're dividing the student in terms of the entire population. And then we are multiplying that to the sample size. Let's say, for example, our population is 600. Okay. Oh no, let me just have this one because this is in terms of a class, just to be consistent with your example there. So let's have that one in terms of a class. So in a classroom, there might be 30 students in a class. So this is our population. Now, I wanted to have there a sample size in which it's gonna be um, 6. Let's have that one. So my sample size is 6 only. And then, out from that population, I've grouped them according to girls and boys. So I have here, let's say for example, in this 30 students, I've got 17 girls and I've got also 13 boys. So out from that, we can just simply select our sample in just dividing this one by 30. That's the population. Also this one by 30. So more likely we're just getting the percentage of that one based on our population. And then we are going to multiply the result to the sample size, which is 6. And so with the other group. Because in stratified random sampling, we are going to get representatives from each of the group. So no group must be left behind. Every group there must have a representative for your sample. So that's stratified. Now, computing that one, so we have there 17 divided by 30. That will be equal to 0.5666. That's non-terminating repeating decimal number. So we will be multiplying that one to 6. And we have that as 3.4. So this is now equal to 3.4. Next one, we go for the boys. We have 13 divided by 30. And then we multiply that one to our 6. So that is now equal to 2.60. Now, you might be wondering, what am I doing here? Why am I not rounding it off? Where in fact I'm having the example here as a student. So, because later on you might be encountering problems if you rounded off that one right away, because it might exceed to your number of sample size. Because right after that one, we'll be adding everything up and check whether we've got the correct sample size. So that will be based on how we are to round off our result in there. So looking at it, we have 3 as a whole number and 2 as a whole number. So that adds up to 5. So we need one more. So that one more will be coming from 0.60 here because that is bigger than 0.4 or 0.40. So that is how we are going to know where to add one more because we lack one more there. We have 3 and 2 on each of the groupings. So we are with sample size as 6. So we'll be adding one more. So this is going to be our 3. And then this will be our other 3. So that means we have here from the boys, we've got to get 3 representatives for the boys. And then we have 3 representatives from the girls as well. So that comprises our 6 samples. Now, the question is, how do we choose the 3 students on the girls and the 3 students on the boys? So this is now going to come in the random sampling. So since this is random sampling, so our choosing on the 3 representatives on each of the groupings there will be based on simple random sampling or systematic random sampling. So you will be picking names based on, might be drawing let's draw by lot. You can just pick on the names there on a container, and those three names will become your sample for the girls and for the boys. So that is how you are going to choose your sample based on stratified random sampling. Next, we are going to move on to cluster sampling. I hope that you will not be confused over cluster sampling and stratified sampling because they are somewhat the same. Now, how are they the same? When you say cluster sampling, this is also in terms of groupings. But the grouping here, you will be taking the grouping as heterogeneous, meaning to say it's gonna be without consideration as they will have their similar characteristics. So that is cluster sampling. Now, you have a grouping there, and of course, the way it is chosen is different from stratified because when you say stratified, you are choosing from each of the groups in there. But when you say cluster sampling, you will not be choosing members from each of the group, but you will be choosing the entire group as a representation for the sample. So that is cluster sampling. Let's say, for example, you are studying on a farm. So take note, our population might not be for people only, but you can have different species in there. That's still population. As long as it refers to the entirety or the whole group, that is population. Now, let's say, for example, your topic of the study is about the farm. So, you, of course, will be testing out what is in the farm. So, the way of testing out for you is you are grouping this according to the column there of the plants, and you are calling this one as region. So, you can group them according to regions. And in choosing, since you are doing cluster sampling, in choosing that one out from the entire regions here, from every regions, you will just be choosing only groups. So let's say, for example, this is a region 1, region 2, region 3, region 4, 5, 6, and so on. Now, in choosing for the groupings, of course, since this is under random sampling, so you will also be drawing by lot the numbers based on the regions there. So you will have their numbers 1, 2, 3, 4, 5, 6, and so on. And then you are going to place that one in a container and you will be drawing by lot. And the number that you've drawn in there will be part of the sample. Let's say, for example, you've drawn on region 4. So that means to say that the entire plant here on region 4 will be part of your sample. So that is cluster sampling. And if you wanted to test out 2 regions, then go ahead. You can just pick another number on the container in there, and that will serve as part of your sample as well. So that is cluster. Cluster is you choose your sample by groupings. Stratified, you choose your sample based on each of the groupings, and you will have their members only of the group as your representative for the sample. So that is cluster sampling and stratified sampling. Now, let's go to the last one. And by the way, before that one, let me just have an example. Here is another example. Let's say, for example, you're in a classroom, in which classroom you've got their seating arrangement in terms of columns, then that might be your groupings. So in terms of columns, your members in there might be boy or a girl, so that becomes heterogeneous already. So from that, if you wanted to choose sample, then you will be just choosing columns or a column. That is again by means of random sampling. So you will have to choose the numbering from the container, and you will be drawing by lot on which column will be part of your groupings or sample. So that will be your cluster sampling. Next, we go for the last one. We have multi-stage sampling. Multi-stage sampling, this is only applicable if you've got a very, very large population. Let's say, for example, your population is the entire Philippines. And mind you, it has a lot of people in the Philippines, or we've got a lot of people in lots of people in the Philippines, more likely millions of people. So if that is the case, then you have to do multi-stage sampling. What is multi-stage sampling? Multi-stage sampling is a selection of which you will be using combination of sampling techniques for the different stages of selection. Okay, so there will be more stages here. Let's say, for example, you wanted to do a survey on the national election. So you will be surveying the voters or possible voters for the national election. So that means the entire Philippines. But since you are choosing only a sample, so you will be starting off by regions. So we go for regions. And in choosing regions here, you may have to do it randomly. Okay? So in which you will be using lottery, or you can use systematic or simple random sampling. So you can just pick on the regions on a container, and whatever region will be obtained through the selection, then that will be part of your sample. But again, when you talk about regions, that's a lot of people still. So you wanted to break it down. So breaking it down, you can go for choosing, let's say, cities. In choosing cities, you may have that one through lottery as well, or you can have that one through systematic random sampling. That's still okay. Now, after that one, since for the city, you've got a lot of people as well, so you are to narrow it down into, let's say, for example, barangay. You wanted to have the barangay now. So in that one, you can have it under stratified in choosing that one, in which you will be grouping the barangay per division or district. So you can have that one. Now, after the barangay there, you can narrow it down into sitios. That is possible. And this one here might be done by another method. You can have their clustering. So this is now an example of multi-stage sampling. As you have noticed, you are now breaking down your larger population into smaller sample. So that is multi-stage sampling. So those are now the different techniques in doing random sampling. I hope you learned something. And I'll be also discussing on my next video the non-random sampling technique. So kindly stay tuned, and please like and share my video, and please subscribe and hit the notification bell so that you will be updated on the latest video. Bye and have a nice day, everyone.